Hi algebra students, today we're taking notes on multiplying radicals. So if you remember the last time we took notes we were on page 6, so this is going to be on page 7. We're going to be multiplying radicals. And remember radical just means that symbol, right? So we're going to be multiplying square roots, cube roots, and we're going to be following a few steps in order to multiply. You're also going to need to put your skills of simplifying to use today. So step number 1 is going to be radicals must have the same index to multiply. So remember, the index is that little tiny number that sits right in the check mark of the radical. And so all this means is that we are not going to be able to multiply square roots times cube roots. So you either have to have 2 square roots that you're multiplying or 2 cube roots. You can't mix and match. So that's the first thing to check for, is make sure the indexes are the same. Same index is the key there. Number 2, we're going to multiply the coefficients. Now remember, coefficients are the numbers that sit on the outside of the radical symbol, and so we're going to multiply those first. Step 3 is to multiply the radicands. And remember, the radicand is the thing that's actually underneath the radical symbol. The radicand is sort of inside. If you think of coefficient outside, radicand inside. And then step 4 is to simplify. If possible. It's not always going to be possible to simplify, but we always need to check. And remember, that's what we learned in the last set of notes and practice that we did. Alright, so let's jump right into an example. Example number 1 of multiplying radicals. So let's start with the square root of 10 times the square root of 14. Alright, first thing we always want to check for is, do they have the same index? Well, this is a square root, this is a square root. Yes, that has an invisible little 2 right there. That has an invisible little 2. We're taking the square root of both of those. They are the same index, so we're ready to multiply. Check, and good. Step 2, multiply the coefficients. Now, coefficient is the number that sits on the outside of the radical symbol. Is there a number on the outside of the radical symbol? Well, yes and no. There's actually, this is 1 square root of 10 and 1 square root of 14. So there's kind of, yes, there is a 1 out in front of here, but we really don't write it. We really don't need it. So there's nothing to multiply on the outside because, again, 1 times 1 would be 1. So the next thing we're going to do, no coefficients to multiply. We are going to multiply, though, the radicands, and that's the number that's inside the root symbol. So we're going to multiply 10 times 14. Use a calculator if you need to, but multiplying by 10 is easy. You just add a 0. So that's going to be 140. Now, it's not just 140, because we're not just doing 10 times 14. We're actually doing the square root of 10 times the square root of 14, which ends up with the square root of 140. So we keep our square root symbol, but we do multiply the things that are on the inside. So we get the square root of 140. That is the third step. We've multiplied the radicands, and now we simplify if we can. So we're going back to what we did last set of notes and last topic. We're going to break this down. So 140 actually breaks down into 14 and 10, neither of which are prime. 14 will break down further into 2 and 7, which are both prime. 10 will break down into 2 and 5, which are both prime. So I'm going to rewrite the square root of 140 as 2 times 2 times 5 times 7. If you feel like you didn't get enough practicing simplifying last topic, you're definitely going to get some more practice this time. So prime factorization, remember our index here is 2, so we're looking for groups of 2. Circle, we've got a group of 2 2's, 5's alone, 7's alone. We're going to move that outside as a 2. And so your answer is 2 on the outside. 2 gets moved outside. Square root of 5 times 7 is 35. And similarly to our last topic, you can always check yourself in Desmos by typing in the original problem, which was the square root of 10. So square root of 10 times the square root of 14. And again, we're not so much interested in this decimal approximation because it's really long and really messy, but we are interested in knowing, is that the same thing as 2 times the square root of 35? And so 2 square roots of 35 do end up giving you the same decimal approximation. So you can always check yourself in the end. All right, let's look at example number 2. So for example number 2, we're going to deal with some radicals that actually have coefficients. So let's try to simplify 2, or to multiply 2 times the square root of 10 times 3 times the square root of 14. Now, we have the same numbers inside here, and I'm just doing that to make this process a little simpler because we've already simplified it. But we already know that the square root of 10 times the square root of 14 is the square root of 140, right? We've already done that. But the difference here is that we do have these coefficients out in front. So remember, our step 2 is, well, we check, make sure the radicals are the same. But step 2 is multiply the coefficients. So if there's numbers on the outside, all you're going to do is multiply those as well. 2 times 3 is 6. So there's going to be a 6 sitting outside. Then when you multiply the radicands, we get what we did before, which is the square root of 140. So the only difference here is that we had to multiply the 2 and the 3 on the outside before we multiplied to get the square root of 140. So 6 square roots of 140 is what we get when we multiply these two numbers together. And then similarly, we're going to simplify again. Now we already have a 6 outside here though. So I'm just going to look back up to my prime factorization here to get what the square root of 140 was. So, but make sure you bring along the 6 that was on the outside. So 6, and then the square root of 140 became 2 times 2 times 5 times 7. And we know that we moved out a 2. Now, normally, and above in this problem, we would have just written that 2 on the outside of the radicand, or on the outside of the radical symbol as the coefficient. Here we already have a 6, so I'm going to have to multiply. Don't add. A lot of people want to add and say, oh, well, there's a 6 and then there's 2 more, so that must be 8. No, remember, we're multiplying all this together. So 6 was already outside times 2 is coming out, so they're going to be multiplied, and then we have the square root of 35 left on the inside. 6 times 2 is 12, and so the final answer will be 12 square roots of 35. And again, similarly, you can check and make sure that you get the same decimal approximation for both. So we had 2 square roots of 10 times 3 square roots of 14, and so that came out to be about 70.99, and we just want to make sure that 12 times the square root of 35 is that same decimal, square root of 35, and it does. You know you've done something wrong if these two decimals do not come out to be the same. Alright, so let's do another, this is example number 3. Let's throw in a variable. Let's throw in some letters. So let's do 4 square roots of 5g times the square root of 2g. And let's actually make that a -4. Let's put a negative out in front of there. So again, we want to make sure that we multiply check and make sure the indices, or the index, is the same on both of them. Yes, they're both square roots, and so we can actually multiply them. Now, we're going to multiply the coefficients first. So what is the coefficient of this first? Well, there's a -4 on the outside. But what did we say is out in front of something that you can't actually see? There's actually a 1 there. And so we're just going to do -4 times 1, which would have just been -4 in itself. So -4. Now we're going to multiply on the insides. So underneath the radical symbols, or the radicands. Now we've got numbers here. So 5 times 2 is 10, and we're going to make sure that it goes under the radical symbol. But now we have g times g. Now, g times g we could write as g squared, but remember, we're just going to be breaking this apart again, so you could just write that as g times g right next to each other. Because now we are going to have to simplify. And when we start to break down, the negative 4 is going to stay outside. When we start to break down 10, what do we notice? 10 is 2 times 5. And those are both prime, and even if you tried to expand them and write them out as the prime factorization underneath the radical symbol, and remember we want to make sure we write our g's twice because that's g times g, is there a pair of numbers that we can take out here? Well, no, there's not two. We're looking for groups of 2 because the index is 2. There's not 2 2s, there's not 2 5s, they're on their own. So we just have to keep our numbers here. There is nothing that you can simplify to take outside here. However, there is a group of g's. And so the g is going to go outside and sit. And so our final answer is negative 4 g. We took out a pair. The square root of 2 g's is just 1 g. And on the inside, we're left with the square root of 10. And similarly, again, because we don't know what g is, it's hard to check this in the calculator. But we do want to make sure that we're getting the right amount of g's on the outside. All right, so that's how you're going to do if you happen to have variables along for the ride. And then the last thing that I want to do is a cube root, because sometimes your index is cubed. So example number 4, and this will be our last example for multiplying. Let's do 6 cube roots of 7x squared times the cube root of 32x. And so we follow our steps up above. First, do the radicals have the same index? Well, yes, it's changed now, but they both are cube roots this time. And so it's okay to multiply a cube root times a cube root. The only thing that would be bad is if this were a square root and this were a cube root. If that's the case, there's nothing to do. You just have to say there's nothing for me to multiply here. So index is the same. Multiply the coefficients. 6 is here. Is there a number here? Yes, there's a 1, but it's just going to be 6. So 6 is going to go on the outside. Cubed. On the inside, we're going to multiply 7 times 32. And again, you can type that in your calculator. 7 times 32 is 224. And now here we have x squared. So that's xx, remember, that's x times x. And then we're multiplying it by another x. So x times x times x, 2 x's, 1 x gives us 3 x's, and we're going to have to put that in the power. That's going to be the exponent. Because we're multiplying 3 x's, x times x times x. Not 3 times x, but x times itself 3 times. And so we're ready to do our prime factorization. Remember, there's nothing to do with the 6 yet. He's just hanging out outside. We're dealing with simplifying what's inside right now. So we're going to do the prime factorization of 224. This is the simplify step, right? So 224 will break down into 4 times 56. I'm going to have to do this very small because I'm running out of paper down here at the bottom. 4 will simplify to 2 times 2, which is both prime, so that's good. 56 has to break down. Let's break it down into by 2. You can divide 56 by 2 and you get 28. Sorry, not 18. 2 times 28. 2 is prime. 28 will break down into 2 and 14. 14 will break down into 2 and 7. And I'm circling my primes as I go along. So I'm going to come back up here and rewrite this. 6 on the outside. Make sure you remember to write that cube root. We're not dealing with a square root, but a cube root this time. And then in order, make sure you get all those 2's. It's 2 times 2 times 2 times 2 times 2. That's 5 2's times a 7. And then how many x's do we have? There's 3 of them. So at the end, I'm just going to write x times x times x. Make sure you expand your variable if you need to. Now I'm ready to go through and gather up my groups. Now, again, pay attention to the index here, because am I going to be circling pairs? No, and that's a very common mistake, is if you're trying to, you get so used to circling pairs that when you do get to a cube root, make sure you're circling groups of 3. So we can only move out 3 here. There's two 2's, but there's nothing to do with them. 7's alone. There is a group of 3 x's though. So those are the things that are going to go on the outside. So on the outside we already have a 6. Make sure he stays out there. Don't forget about him. Don't just write a 2 and an x. It's going to be 6 times 2 times x. Those are the things moved on the outside. Write your radical symbol. Make sure you put that 3 index. Don't forget about the 3 index, because if you forget to write it, it becomes a square root. We don't want to change cube roots into square roots. Make sure you put the index. On the inside, we're left with 2 times 2 times 7, which is 4 times 7 or 28. And then we've got a little bit of math to do out here because 6 times 2 is 12. So your final answer is 12 times x, cube root of 28. So make sure you're using the steps 1 through 4 to practice with and to work on all the practice assignments and also the quiz. If you can multiply numbers together and also simplify radicals, that's all there is to multiplying radicals.